Hi sir, this is Meghnad from ECEA bearing the roll number 23BQ1A0431. In this session, I am going to discuss about modulation, demodulation, classification of modulation, advantages of modulation and multiplexing and its classification, and frequency division multiplexer. Now let's look into the concept of modulation. Modulation is the process of changing some characteristics like amplitude, frequency, or phase of a carrier wave in accordance with the instantaneous value of the modulating signal. It enables the efficient transmission of information over long distances and through various media. Now let's look into some key elements in modulation. The first one is carrier signal, a high frequency signal used as base for modulation. The second one is message signal. It is the information or data to be transmitted, also called as the modulating signal. Modulated signal is the resulting signal after modulation which carries the information. Now let's look into the concept of demodulation. Demodulation is the process of extracting the original message signal, that is information, from a modulated carrier signal. It is the reverse of modulation and is performed at the receiver's end to retrieve the transmitted data for processing or interpretation. Now let's look into the key elements in demodulation. In demodulation, we have two key elements. They are modulated signal and demodulator. Modulating signal is the received signal containing the carrier and the embedded message, whereas the demodulator is a circuit or a device that recovers the original message signal from the modulated signal. Now let's look into the classification of modulation. Modulation is broadly classified into two types. They are continuous wave modulation and pulse modulation. In continuous modulation, again we have two types. They are linear modulation, angle modulation. In linear modulation, it is classified into again four types. They are amplitude modulation, DSBSC, that is double sideband suppressed carrier, SSBSC, that is single sideband suppressed carrier, and VSB, which is vestigial sideband. Again, in angle modulation we have two kinds. They are frequency modulation and phase modulation. Now the second type of modulation is pulse modulation, which is classified into two types. They are digital modulation and analog modulation. In digital modulation we have PCM, and analog modulation is classified into four kinds, that is pulse amplitude modulation, pulse width modulation, and pulse position modulation. Now let's see what are the advantages of modulation. Advantages of modulation: reduces the height of the antenna. Modulation avoids mixing of signals and increases the range of communication. Modulation also allows multiplexing of signals and allows adjustments or changes in bandwidth. It also improves quality of reception. Now let's look into the advantages of modulation in detail. The first one is modulation avoids mixing of signals. Without modulation, multiple baseband signals would occupy the same frequency range. This can lead to the interference and signal overlap. Modulation assigns distinct frequency bands to each signal, ensuring that signals do not mix or interfere with one another during transmission. The second one is modulation increases the range of communication. Low frequency baseband signals cannot travel long distances due to significant attenuation and energy loss. Modulation transfers the signal to a higher frequency range, that is radio waves, which can travel longer distances with less attenuation. This extends the communication range. The third one is modulation allows multiplexing of signals. Multiplexing is the process of combining multiple signals for transmission over a single channel. Modulation enables techniques like frequency division multiplexing (FDM), where different signals are transmitted on different frequency bands, allowing efficient use of the communication channel. The fourth one is modulation allows adjustments or changes in bandwidth. Modulation helps control the bandwidth of the signal to match the channel capacity. For example, high frequency carriers can support larger bandwidth, allowing more data to be transmitted efficiently without signal distortion or loss. The fifth one is modulation improves quality of reception. High frequency signals are less affected by noise, interference, and other distortions during transmission compared to low frequency signals. By modulating a signal onto a high frequency carrier, the quality of reception is significantly improved, ensuring better clarity and reliability of communication. The sixth one is modulation reduces the height of antenna. For efficient transmission of signals, the height of the antenna should be proportional to the wavelength of the signal. Baseband signals, like low frequency signals, have large wavelengths requiring extremely tall antennas for transmission, which is impractical. Modulation shifts the signal into a higher frequency, reducing the required wavelength and consequently the antenna height. This makes the system more feasible. Wavelength equation is given as lambda equal to c by f, where c is the velocity of the light, which is equals to 3 into 10 power 8 meters per second, and f is the frequency of the signal. Antenna height equation is given by h equals to lambda by 4, and by substituting the lambda equation in height equation of antenna, we get h equal to c by 4f. Now let's discuss about the concept of multiplexing. Multiplexing is the process of combining multiple signals into one signal over a shared medium. If the analog signals are multiplexed, then it is called as analog multiplexing. Similarly, if the digital signals are multiplexed, then it is called as digital multiplexing. A number of signals were combined to send through a signal cable. The process of multiplexing divides a communication channel into several number of logical channels, allowing each one for a different message signal or a data stream to be transferred. The device that does multiplexing can be called as a multiplexer or mux. The reverse process, that is extracting the number of channels from one, which is done at the receiver, is called demultiplexing. The device that does demultiplexing can be called as demultiplexer or demux. Now let's discuss about the types of multiplexers. Multiplexers are broadly classified into two types, analog and digital. Again, analog is classified into two types. There are frequency division multiplexing, that is FDM. The second one is wavelength division multiplexing, that is WDM. In digital, we have time division multiplexing, TDM, which is again classified into two types, that is synchronous TDM and asynchronous TDM. Now let's look into the concept of frequency division multiplexing, which is a classification of analog multiplexers. Frequency division multiplexing is the total channel bandwidth available to the system is divided into smaller non-overlapping frequency bands, which are also called as subbands, which enables the receiver to separate them and recover them individual messages. The block diagram of a typical FDM system shows the low-pass filter at the transmitter section of an FDM system, removes high-frequency components of the message signal that disturbs the other message signal that shares the channel. These filter signals modulate the carriers having the frequencies FC1, FC2 and FC3 so that the resulting modulated waves do not have the overlapping spectra. The bandpass filter after the modulators are used to restrict the band of each modulated wave to prescribed range. All these three signals are now combined to produce a composite signal S of t, which is then transmitted over the channel. In the receiver end, suitable bandpass filters tuned to the carrier frequencies are then employed to recover each of the modulated carriers carrying the individual signals. Each modulated signal is again passed through a demodulator to get back the original message. In an FDM system, the bandwidth allocated to each subband is slightly larger than the bandwidth needed by each message. The extra bandwidth is called guard band. Now let's discuss about channel bandwidth of FDM system. If n message signals each having a bandwidth equal to Wh, then the minimum bandwidth of the channel should be greater than Nwh. Channel bandwidth of frequency division multiplexer is greater than or equals to Nwh, where n indicates the number of messages to be multiplexed. Therefore, frequency division multiplexing (FDM) is a fundamental technique in communication systems that allows multiple signals to be transmitted simultaneously over a single communication channel by assigning each signal a unique frequency band. This method efficiently utilizes bandwidth, reduces interference, and ensures smooth data transmission in applications such as radio and TV broadcasting, telephone networks, and broadband communication. While FDM offers advantages like continuous data flow and low latency, it also faces challenges like bandwidth limitations and crosstalk. Despite these challenges, FDM remains a crucial technology in modern telecommunications, supporting seamless and efficient communication across various industries. Now, let's look into the applications of frequency division multiplexer. It is used in telephone system, telemetry, commercial broadcast, television, and communication networks. Commercial FDM broadcasting stations uses frequency band from 88 MHz to 108 MHz. These 88 to 108 MHz frequency band is divided into subbands of bandwidth 200 kHz. The FM stations are identified by the center of frequency within their channel. Example 98.3, 93.5, 102.2, etc. These systems can provide radio listeners with their choice of up to 100 different radio stations. So this is about the FDM system. In this session, I have discussed about the concepts of modulation, demodulation, and its classification of modulation, advantages in detail about each of the advantage of modulation and why we need modulation. Then followed by we have also discussed about the multiplexing and its classification, and we have also discussed one of the classification of analog multiplexer, that is frequency division multiplexer, and its applications. By this I conclude. Thank you, sir.